Yeah, I heard the other micro, that mic doesn't work.
Then, yeah, this thing's not working, yeah.
Okay, so Thorsten has a lot to tell us about the kernel, so we'll probably just get started with it now.
Welcome, everybody. Yeah, I've been here a few times already. People know that I'm having a lot of slides and talking a lot. Can talk about what's happening in the kernel for hours. Quick introduction: who am I? Why am I here? Well, 10 years ago, I did a lot of things in Fedora land, and that's why I feel kind of part of the family. On the other hand, at work, I'm writing in Germany. I'm writing for a computer magazine. I write a lot about the Linux kernel. Until a few years ago, it was actually translated to English, some of it. These days, it's only available in English. The other thing I'm doing is, now and then, is regression tracking for the Linux kernel. There was an LWNet article about it a few months ago. And what I'm not is a Linux kernel developer. I'm not a real programmer. But thanks to my work and reporting and regression tracking stuff, I'm having a good overview what's happening on the Linux kernel. And also thanks to lwn.net, it's a great resource if you want to know what's happening in the Linux kernel and how it might impact you in your admin life or programming life. So what's coming? It's basically 4 parts: a short status overview, and then I'm getting over to current developments, and over to more broad changes that are happening, like in the past 12 or 18 months, and or are ongoing for all the time. And then I'm looking a bit at the Linux kernel development itself. And yeah, that's it. By the way, the slides will continue to change this frequently, so that's why I'm actually taking questions after each part, otherwise everyone will have forgotten what he wanted to ask in the end. So, the short status overview. The current Linux kernel is Linux 4.14. It was released mid-November. And the ETA for Linux 4.15 is 30 to 40 hours from now. It's really quite predictable this time. In other words, Sunday night it will get released. It was supposed to get released last week already, but there were a few problems that were actually found in Fedora land, and that's why there was another pre-release, and that's why it's likely getting released tomorrow. As long as nobody else finds any strange problem that makes Linus say, hey, we need another week, but adapt that. So Ubuntu 18.0 will likely use that kernel. That's the plan currently, in case it's of interest for you. Just like all the time, Fedora will get this kernel in a few weeks. OpenSUSE, Tumbleweed, and a few others as well. And basically, in kernel development, everything works as usual, quite smoothly. And normally, this part of the talk could end here already. But well, there was something happening a few weeks ago, and that's why this part is a bit longer. Well, if you didn't know what those logos were, that were the logos for Meltdown and Spectre, a few security issues in most recent processors. And they mixed things up quite a lot. They were published early January, and the kernel developers quickly got to work to fix them. And actually some fixes made it into the kernel, into 4.15, which is going to be released tomorrow, as I said. One, it's called PTI, it's page table isolation, and that's against Meltdown. And for the 2 Spectre variants, for the second of the 2, there was a technical solution, a mitigation that's called red poline. Note the fix versus mitigation. Meltdown is actually a fix. PTI is actually a fix for the Meltdown issue, or a workaround, to be more precise, to actually make sure what Meltdown where the problem is with Meltdown, that it's not exploitable anymore. And for the second Spectre variant, it's a bit more complicated. It's more mitigation. that tries to make sure the security issue doesn't show up anymore and can't be exploited anymore. It looks a bit like this solution is not finished, but it's at least a start which we can rely on for now. Yeah. Both these changes were quite big. It's normally not the case that so big changes are done in the kernel when it's nearly going to be released. In this case, PTI was merged for the RC6, the 6th pre-release. It was early January. That was really unusual that such a big change was done. And Red Poline was actually merged 2 weeks later with RC8. And what was even more unusual is that both features were immediately backported to the latest stable release, that is 4.14.11 and 4.14.14. But with those kernels, you now get protection. To give a little more details about this, for Meltdown, PTA was actually merged a few days before Meltdown got published. It was actually merged into the mainline kernel, that is 4.15, on a day before New Year. And immediately backported on, I think it was 4.14.11 was published on January 2nd, and on the 3rd in the evening, Meltdown was actually published. A few older kernel releases, you can see it here. I don't mention all the version numbers. Also got a PTA implementation. It happened a little bit later. And it's actually a little bit different, the PTI in those kernels. It's a little bit closer to a protection technique called Kaiser that was developed a few months earlier. And this PTI implementation is not that efficient on modern CPUs. There's a technique called PCID, Process Context Identifiers, that PTI can use to reduce the overhead it has. But on the older kernels, it doesn't use PCID that much. So the overhead might be bigger there, but it's depending a lot on your workload if there's a difference. The older solution, by the way, is also the one that most distributions picked up to protect the kernel against Meltdown. AMD CPUs, in fact, if you're having one, you don't need to care about all of that because AMD CPUs are not affected by Meltdown, and that's why PTA is automatically disabled there. According to AMD, yeah. That's the problem with all of that. We have to rely on the CPU vendors up to a certain point. Yeah. How much PTI slows down the system actually depends on CPU, software, and workload. If you're doing crypto mining still on your CPU, then you actually won't see any big change due to PTI because it's just doing it in user land and it doesn't care at all. But there are use cases on servers likely where it could have a bigger performance impact. Another detail, if you're still running a 32-bit installation on x86, that there is no PTI for those machines yet, but it's being developed and likely will get finished soon and then get merged into the latest kernels. I think distributions also don't have fixes yet. And about the performance impact, again, if you want to test how big the performance impact is, there are kernel arguments that's called PTI. Now the projector, whoa, where did that come from? There's a kernel parameter that's called no PTI where you can disable it, and then you can do benchmarks to see how big the performance impact is you're seeing. That was it about Meltdown and PTI. Now we're getting to Spectre, actually. I often pronounce this wrong, sorry. To be precise, we first go to the second variant of it. It's called also branch target injection. And Red Poline was actually merged mid-January for the 8th pre-release, so like 2 weeks ago. And there's one important detail: for full red poline protection, you need a compiler that actually does a few specific things. And one of those compilers that can do this is GCC, the version 7.3 that was actually released 3 days ago on Thursday. Fedora, for example, already uses this in the latest kernel they ship. The red poline actually is supposed to have nearly no performance overhead impact. That's at least according to the developers. Remains to be seen if that really is the case or how that works out. But there are also kernel parameters available, flags where you can disable it. In this case, it's no Spectre underline v2. Then all those protection will get disabled. It's actually from the kernel parameters file in the kernel documentation, so if you want to look those up later, that's easily found there. Detail about red poline does not depend on the new BIOSes that a few vendors released or the new microcode that a lot of Linux distributions ship as an update. Nevertheless, those BIOSes or the new microcode might be or is important for virtualization. For example, if you're running a Windows machine on the KVM, because it needs those commands available in the VM to make sure Windows can protect itself there. And there's a lot of noise about more Spectre mitigations on the Linux-Kernel development list. Actually, it made the news a few days ago. Linus said a few things and wasn't really nice to Intel. I guess a lot of from you have seen that. That was part of the discussion. What else remains to be done? One of the things that's under discussion is red poline might be not protecting fully on the latest CPUs like Skylake and later. Maybe improvements need to be made to make sure it works there, or maybe the kernel will also be changed to use the new microcodes and BIOSes there, because on those CPUs, those protection from the microcode has not that much of an overhead. As I said, for virtualization, those microcodes are needed, and maybe some of those enhancements that are coming will depend on the microcode also. Red Hat Enterprise Linux, SUSE Enterprise Linux, and Ubuntu actually don't use red poline. And they use a mitigation that needs the microcode, or to be precise, the new commands, instructions that the new microcode brings to the systems. Here are the 4-letter acronyms, or 5 if you want to look them up. That protection scheme actually has way more performance overhead. There were a few benchmarks on the net and from Red Hat also published where you can see this protection has more overhead. That's why it looks like those vendors will also switch to red poline sooner or later. But I guess they wait until things are settled a little bit more. Let's wait and see about that. And get to the third issue, that it's the first Spectre variant. Patches to protect against that are work in progress. They're actually circulating for 2 or 3 weeks already, and some of the vendors actually picked them up and integrated them in their kernels. Some of the protection also benefits from compiler support too, but it's a different one. And those patches will actually change code. They don't add a new protection solution into the kernel protection technique. They actually, the kernel developers actually look at code that might be exploitable and change it there. So this is something that is an ongoing effort. In the next few years, they have to look to make sure they don't introduce any new problems. Patches are proposed, will likely make it to 4.16. Yeah, and that's basically it about Meltdown and Spectre. Just one more thing. There's a way you can check if your CPU is affected by which of those problems and what the kernel is trying to do against that. Does this thing? Yeah, there's this. You can simply look into this file of S under sys devices system CPU vulnerabilities, and there are files for Meltdown and the 2 Spectre variants, and the kernel shows there what if your CPU is affected and what it's trying to do against it. If they are missing, then it's likely that your kernel doesn't do anything. But those files might also actually be missing on some of the vendor kernels. So, enough about that. Questions? Or did you have enough about that?
Is there talk about automation of the vulnerability checks in the kernel with regards to Spectre v1?
Heinz asked if there's a kind of automation to make sure that the Spectre variant 1 solutions, the problem errors don't come back. I think it's way too early to talk about that because there's so much still in the flux about that that nobody is thinking too much about that yet. But there are a few people already talked about that, yeah. So in the longer run, I expect something like that will come. I actually have, for people that are asking questions, nice Fedora bag. Do you want one? Yeah, well, stay. Up. Oh, yeah. Another question? I have 2 more. Or are you all now scared now? Well, if there's no more question, then I move on to the second part. Oop. Yeah. So, what happened in the past few months? One thing that happened right now, basically, is drivers for AMD Radeon graphics card really got good. To be precise, that is something AMD has been working towards for 10 years, and we are now at the point where I'm, for the first time, able to say, hey, they managed it. All the latest graphics cards are supported. All the major features work. So we're getting to the point where AMD is not so much worth than Intel, that it's supposed to be really good. The graphics cards are supposed to be really good. That's at least what everybody says. Because if you look closer, it's also not all fine. Yeah. That doesn't. That it's part of it is the kernel drivers, but also the userland drivers. The 3D driver in Mesa, for example, also got a lot of improvements over the past few years. And these days, in benchmarks, it's not. It's basically on the same level as a proprietary driver with everyday games. Sometimes the open source stack is better. Sometimes it's worse. It's not so much of an issue these days. And also the driver supports nearly all the features, all the major features at least, like GPU, like using your graphics card for computation. That's a thing where there are still problems, but AMD is working on it. Did it come back? Yeah. Yeah, one important thing about that, to make sure you get those good AMD drivers, you might need Linux-Kernel 4.15, because there's one important change that happened there that's called DC, or used to be called DAL. That's a big change to the driver that got merged in this version, and that, for example, also brings proper support for AMD Vega, the latest graphics cards, but also for the older ones improved by that. But for them, you might need to set a kernel parameter to make things like audio via DisplayPort or HDMI work. One thing I want you to take away from this talk is stop bothering too much about the proprietary AMD drivers. It doesn't work too well on a lot of distros anyway. It's more AMD more and more optimizes this driver for high performance computing or CAD and all those enterprisey world things. And on everyday distros like Fedora, it doesn't work. It doesn't often work. It does, not work often. So it's you have no choice there anyway. And another thing I want you to take away is if you're not a high-end gamer, consider avoiding NVIDIA GeForce, because there is a good open source driver stack for 3D graphics that works quite well these days. It might not be perfect, and it might not be that fast as NVIDIA's hardware is, but it's quite good. What else is happening in the kernel? In the file system era, there's happening quite a lot. XFS is getting a major overhaul. It's actually the fourth or fifth, I think, in the past 20 years. And yes, for those of you that have been here last years, I mentioned that last year already. Actually, XFS developers are working on features like copy on write, deduplication, online FS check, and a few other things. If you're interested in file system, that's actually file system features a lot of people like about ButterFS and ZFS. So XFS is trying to catch up there a little bit. What XFS won't get is volume management. That's in ButterFS, ZFS also. It will leave that to MDADM or device mapper. And so the management won't be that easy like in ButterFS or ZFS, but there's a technique called Stratis under development in the Fedora and Red Hat world that is supposed to make everything a little bit easier as well. Those improvements to XFS are still quite in the work. Online check and repair, like an FS check, actually was merged into 4.15, but it's not really usable yet. Yeah, so while talking about file systems, people always ask, what about ButterFS? Well, there were no really big changes recently. A lot of small improvements and fixes here and there. But nevertheless, they made ButterFS better, but some parts of it are still considered unstable. And one of this is, or the major one actually is, the RAID 5 on 6 support. So be careful about using that. You can use it if you know what you're doing. There's actually a document in the ButterFS wiki where you can actually see which features are considered stable and which features might have a few problems. And then you can check actually if those problems might be relevant for you or not. And actually, in case you're wondering what kind of file system I'm using, I'm actually using ButterFS. I actually started doing it 2 years ago while I was writing articles about ButterFS, just to give a bit first-hand experience. On a laptop, on a desktop workstation, it's kind of nice sometimes to have the snapshot function. I might use it also on more for backups. If I had a server with ButterFS, which I don't, I use ext4 there still. So I'm trusting it kind of, but also not fully. But if you're wondering, Facebook is actually using ButterFS heavily internally. OpenSUSE and SUSE Linux Enterprise use it by default. For the root partition, actually not for data, their XFS is also being used. So will ButterFS soon be finished after like 10 years of development by now? I have no idea. The interesting thing that happened there, in case you missed it, Red Hat Enterprise Linux actually kind of kicked ButterFS out. It wasn't really part of Red Hat Enterprise Linux. It was a technology preview, and those are sometimes, the preview features are for testing, and Red Hat considered, okay, we don't want to invest anymore into that. It will stay in RHEL, but RHEL 8 might actually miss it. They simply said they want to use other techniques, and I guess the XFS, which they are using by default by now already, will get more important there. SUSE, on the other side, is still fully committed to ButterFS, and yeah, that's interesting because, I mean, both file systems, XFS and ButterFS, have their pros and cons. They have their strengths area and weak areas, and the same holds true for ext4, which is also still quite used a lot. Yeah, and I think that's a good. Good as there we see a bit of competition there, because one size doesn't fit all. That also holds true for file systems, and I mean, in the end, it's not that hard to switch from one to the other on a new install or something. And it's not a religion. People sometimes get really focused or when it comes to file system. Yeah. Yeah, interesting times ahead. We'll see what happens there. And remember, ext4 is getting improved as well. Not so much as the other two, but there are still changes every now and then. I won't go into that detail here because there's no time for that. What else? A lot more. What's upcoming is support of VirtualBox. A few drivers are actually already in the kernel. A few will likely merge with 4.16, so that means that distros will simply get those drivers with their next versions, and you don't need to install the guest drivers if you're running Linux under VirtualBox. So now it's gone again. Now I myself can't even see what I'm talking about. What was also there? Linux will get HCDP protection for Blu-ray playing. I guess on the desktop it won't matter that much because nobody uses Linux for this. So now everything. No. I guess there it is. I'm seeing again something.
The only option is to switch to VGA.
Yeah, we try to switch to VGA. Better? Oh yeah. ALPM is also something I want to talk about. That's a power management technique for your SATA drives. A lot of laptops manufactured in the last 5 to 6 years and don't use it properly, and at least not if you're not enabling it yourself with something like PowerTop or TLP. And that's why your processor and your hard disk or your CD-ROM drive, DVD drive, consume about 1 to 2 watts of power all the time, and that's really bad for your battery consumption. So someone from Red Hat is actually working on it to make sure the kernel enables it automatically. Fedora 28 will actually try to use this mode, and so your laptop might have half an hour or an hour more battery time with the next kernel. There was a big C group renovation happening in the past few years. The last major roadblock was solved with the CPU controller that was merged into 4.15. If you're interested in licensing the kernel now, the kernel developers started to make add headers to all the files, what the license of each and every kernel file is. The Linux kernel also got support for an open instruction set architecture called RISC-V. There are no real processors out there, but Western Digital plans to ship a few million in the next few years. And there's actually work being done to use to encrypt the memory on the latest AMD processors. They have a function for that. The kernel starts to support that. Kernel live patching is changing the kernel while it's running to avoid rebooting with in case there are security problems, smaller security problems. There were a lot of changes there to make sure that works in more cases. And if you're into I/O for your server and programming, there are lots of improvements for asynchronous I/O that somebody is working on. Yeah, that was the part where I'm talking about the stuff that's happening in the last few months.
Looking at how your laptop is losing connection, Do you have Radeon GPU inside?
No, I have an Intel CPU inside, and I think it's the adapter. That's the problem, or maybe the projector here. I've seen it in other rooms also. That they are not so good. The question was about VirtualBox support. This is when running at the guest. That's what's right now being done, merged into the kernel. Yeah. Plans for the host side? I'm not aware of it. I have no idea. You could drop me a mail, and it's an interesting question, and I can look it up. But I guess that's first the guest and then the host, maybe. Yeah. Do you want? Of course. So it's So any more questions? I need a drink anyway. Otherwise, my voice will be. So then I continue. So important changes. There's one thing, not really a technical change, is that we get one kernel that gets supported for 6 years now. That's 4.4. It got a lot of media attention because, the long-term and stable kernels from normally get only supported for 2 years, and they said, hey, everybody was happy and said, okay, that will improve the Android solution, that we have a kernel that's supported for quite a while. But as my friends from the media, as I said, I'm also a journalist. That's nothing new. It's a little bit oversimplified, but we already have kernels that are supported for 5 or 6 years. It's actually Ben Hutchings that is doing it. He's actually maintaining a few kernel releases, picking them up when another developer stops supporting them, because those are those releases that Debian uses, and Ben actually supports them there, and Debian release actually with LTS and all this other stuff also comes up to 5 years of support, together with a bit room ahead. There were a few kernels already that got supported for 5 or 6 years, or are still planned to get support. 3.2, for example, was one. Its support lifetime actually will end in May if everything gets as planned, and then it were 6 years in the end anyway. So this 6 year support is not really new. Maybe it might change a few things because companies now see that somebody committed, that Greg Hartman committed himself, but maybe that is just won't change much. New kind of system sleep, if you was developed and is now supported by Linux. It's not available on all machines these days, but the Ultrabooks kind of systems, like my XPS 13 from Dell, or the Microsoft Surface hardware, and I think the IBM Lenovo ThinkPad X series also gets it. It's called Suspend to Idle, or S2 Idle, or S2E for short, S2I for short. In the Windows world, it's actually called Modern Standby, and what that does is it basically suspends all the hardware which with suspend techniques that can be used during runtime. Normally, you might know S3 or suspend to RAM. There, everything gets shut down, and only the memory gets power. And with this, your machine is basically running, but all CPU, monitor, and everything is simply powered down, but can immediately wake up again. So it's more, the power consumption there too is higher. But the system wakes up way more quicker, and the Wi-Fi can stay connected. And so you basically put your laptop lid on, open your laptop lid, and you can start working. And that has benefits. I don't like the higher energy consumption it has while the system is sleeping. That's why I actually disabled it for my machine. Here it works, but there are actually some systems where the traditional suspend to RAM actually doesn't work anymore due to firmware bugs, so you actually have to use this suspend to idle. No, but normally the kernel will handle it all on your own. What else? There's something ongoing for years now. The kernel is made more secure. Laura talked about that an hour ago here already. That's why I'm skipping a little bit about this. It's or going faster through this. It's not about bug fixes in particular. So, it's more about eliminating attack vectors. So things the bad guys use to take over your machine. The kernel self-protection project is doing a lot of work there. They really merge quite a lot of techniques to harden the kernel against these things, and there's more to come. If you're interested in details, there's a talk available on YouTube from the kernel recipes, the state of kernel self-protection by Keith Cook. Also, like I said 1 hour ago, there was a talk here. You can also look at that. And Case Cook also has a good blog where he's writing about what the kernel developers do. What else? Techniques for performance measurements and tracing improved a lot. Mostly that's thanks to the BPPF. That's improved in the kernel. That's kind of virtual machine you can use to get only to make the kernel process the data to make sure only those data gets to the user space that's important for the user space, and then that makes tracing and performance monitoring more things possible. It's quite complex and hard to use. But there's a tool, utility box, BCC, which quite a lot of utilities written by someone that's an expert there. That's available on GitHub, where you can actually look better into the kernel, what's happening. And that's really worth its own talk, and talks like that exist. A lot of them are from Brendan Gregg. He works for Netflix, and it's really interesting what you can do these days with all those performance measurement techniques in the kernel. If you're interested in this, really go to his blog. It's written down here on the below the image, and read a little bit in the blog, or watch the videos on YouTube from his talks. There's also a perf cheat sheet that's one of the kernel developers recently made. It's available also freely, where you can see how you can use the perf tool to monitor what your system is doing. And what I really want to tell you, if you're a good admin or a good programmer, go and learn that stuff, and in a year or two, ask for a rise at your employer, because you will do better work with those tools. But the learning curve is really steep, so you better be prepared to invest a little bit of more time to learn that. If you're from the Red Hat world, actually even SystemTap is actually also looking into making use of this backend, because one of the things it avoids is that you have to compile a module to to look at what the kernel is doing. What else? There's a lot of things in the networking area happening. Also, thanks to the BPPF that's used in this Express Data Path, or XDP for short. That's mostly to optimize routing in containers or big data centers, for example, also for OpenStack. Facebook uses it a lot. That's one of the things that happened in the kernel recently. Another one is the kernel got an implementation for TLS, so for the encryption technique that is used when you do HTTPS connections with your browser. That way your server side can actually work more efficient, and do the encryption more efficient, and that improves the performance quite a lot. Another thing is zero copy support. So it, your data a program calculates can actually read directly from the kernel and sent out by the kernel. It improves memory copies, and that makes the performance better. Those were just a few things in the networking area that changed quite in recent time. If you're interested in this, go to LWNnet and look for the reports from NetConf and NetDev. There are lots of talks there. Note from the talks what the kernel developers are working on. I find it particularly interesting because networking for a lot of people makes them think, oh, networking is done, there's nothing much more to improve, but that's really not the case. The kernel developers are doing a lot of things there. Yeah, a lot of things is the right word. A lot of things are happening in other areas also. There were block lifetime hints. That's interesting for you if you're admin and want to do storage, because that way your software actually can tell the kernel if the data it's writing is only temporary or something for to do archive or something, and that way it can decide where it's right. It's on the SSD, and that can improve the performance of your storage system or the lifetime, because some data simply then is sent to a different area of the SSD. I'm running short on time, that's why I'm skipping on a few things that I'm here. Yeah, org unwinder, something I find particularly interesting. That's also for debugging, but it's enabled. It's has less overhead than another debugging technique that is normally enabled in your kernels. So this using this org unwinder will actually improve the performance, but that's something your distribution will do for you. Yeah, questions? I see we have actually a perf guy sitting here. If you then, and I still have a bag. Nobody? I'm drinking a little bit maybe then. Reminder, I'm going more to the meta level now. I'm not talking about features anymore. So if you have interest in any features, ask now. No? Who sleeps? Okay.
So, a few years ago, dtrace was the hottest key in the blog when it was for performance monitoring. Is there a good comparison between BPF and dtrace?
The question was about dtrace was a hot thing a few years ago, and the thing is, yeah, actually dtrace is something that was used in the Solaris world, and Linux never had something comparable. And to be honest, I'd say the techniques to do most of the things dtrace can do are now in the kernel, but it's not easy to use yet. Or Arnaldo?
Yeah, I mean, things are improving the BPF. Things are improving. The set of tools that Brendan Gregg wrote. Brendan Gregg, by the way, is one of the guys behind dtrace. He wrote books about it, and he worked together with the main guy. And perf got some support to interface with BPF and then get it as part of its workflow. So I talk tomorrow will be about an attempt of using the perf infrastructure and BPF to implement an alternative to strace. So we're going to have strace using BPF. So I mean, things are happening that are making it more easy to use.
Yeah. Thank you. You're the expert there. So, then I'm moving on. Yeah, 10 minutes. A little bit of look at the kernel development itself. One thing at this point I'd like to mention every time is there are about 2 or 3 minor security issues in the kernel every week, a few moderate issues each month, and a critical nearly about once a year. So better be prepared. Those problems might show up when you're on holiday, and then you might need to update your kernel and everything. What else? Testing and regression tracking are a problem. That's actually my pet peeve because I'm a little bit involved there. Bug reporting for the kernel is still quite hard. There's a Bugzilla instance from the kernel developers, but it's not really used that much. Only some subsystems use it. Running the latest kernel sometimes is hard. And the kernel has, from my point of view, too few testers because there's so much hardware out there, and no test lab can test that. That's something where the community needs to get involved more, and the kernel developers need to make it easier to make kernel testing something a lot more people can do. Lots of room for improvements and community participation. So if you're interested in these things, simply get to work and do something. There's a lot of things. If you wonder what you can do, simply ask me. What else? Something I noticed in the past few months. As I said, I'm a journalist myself. The online media, Reddit and what they are called, are playing Linus said more often. It seems they simply look at the kernel mailing list and all the messages from Linus, and if he's saying something bad about something, some other developer or some company, hey, it's getting a headline. Yeah, why are they doing it? Yeah, well, the online world, every click, every page view is money, is advertisement money, and that's influences why this that's why these stories are written. Because if Linus says something, that's something a lot of people are interested in. Thing is, most of the stories are not really good, and because some of the authors don't look that closely into who's talking to whom and look at the backgrounds. So I don't like most of the stories, and I don't think this online media will get to world domination with that kind of attitude. Really, it's not as bad as it often sounds in the online articles or on Reddit comments. Look a bit closer if you read something. Often it's a bit different. Yeah. What else? Another thing I also like to mention here: there are lots of improved drivers with every release. On new drivers, I skipped that because that's most of the time only of interest for those that have the hardware. But to give an example, like 200 to 400 new USB or PCIe devices get supported with every new release. Or to be more precise, are not only devices, but sometimes are device classes, like a kind of class for storage controller. And that, for example, in 4.15, the Intel Wi-Fi driver gets support for 85 new chip variants. That's unusual. I think that it now supports like 500 or 600 different chip variants. But it's a good example of why it's important if you have if you buy a new laptop, that you need to run a fresh kernel on it, because only that might have the drivers. What else? The kernel, as I said, the development works quite smoothly. Every 9 or 10 weeks there's a new release. Actually, you can bet on it. 4.15, as I said, which is coming out tomorrow, is 1 week late. It took 11 weeks to develop, and that's mainly the fault of Meltdown and Spectre. Kernel is also growing quite a lot, about nearly 300,000 lines every release. You can see it here. I did a chart a year or two ago. There it maxes out at 21 or 22 million. These days we already are past the 25 million lines of code. That actually includes documentation, comments and blank lines. To give a quick example how far the development, how quickly the development happens. This is between the 4.8 release and the first pre-release of 4.9. There's 13 days, and there are really about 15,000 commits happening in that in those 2 weeks. That's basically one change every 97 seconds. So it's really fast. But that's the main development phase of the new kernel. And after that, it gets a little bit slower. Desperate at speed, everything works closely, works very well. If you're interested in things like that, there's a Linux kernel development report from the Linux Foundation, which has more details like this. This was part 4, close to the end. More details about anything, ask me. Ask me here, I'm staying till tomorrow, or use the search engine. There are slides and recordings from talks available on YouTube, LWNnet, and a lot of other sources. And if you're interested in something and don't find anything, ask me. 3 more things. Like I said, testing the kernel is my pet peeve. I want you to help to get motivate. I want to motivate you to help testing, and that's why I'm always telling that it's really important if you have not that popular hardware in your systems that you test it yourself, or if you're using your distro in an unusual way. Because if you don't test it, nobody might. And then bugs and regressions only get found when they're really old, and finding the root cause then is really way harder. And fixing it, it's really in your interest to test every now and then, and will annoy you in the end. That's why I'm actually talking about that thing tomorrow at this point at 1:30, getting more into details there. Yeah. One more thing, tell me how you liked this talk, or use the webpage to tell the organizers. They will tell me afterwards. And if it was really bad, then they won't invite me again. Remains to be seen. I think I'm here for the 3rd or 4th time, so it can't be that bad. Want to be kept up to date? You can, if you're from Germany, you can always read heise.de. If you're English speaking, go and read lwn.net. And I'm actually also a little bit doing something in English on Google+. Yeah, I know it's not Twitter and not Facebook, but for the open source community, it works quite well there. And you simply can look at this collection there on Google+ every now and then to see what I found interesting because I'm sharing it there. Yeah, that is. That was slide 197. Still questions? Or do you want a coffee now?
Do you have slide number 200?
No. Tomorrow. Come back. Tomorrow I also have more pictures. At least I even had planned to have more pictures, but then Meltdown and Spectre happened, and that took a little bit of time away from my planning for the talk. No more questions? I still have one. Do you? Whoop. Yeah. That's today's boss. Yeah, then thanks for listening. Enjoy the conference. That was actually right on time. I didn't even need the out of time card.
Yeah, the projector gave in.
I've seen it.
It's been doing it in all the rooms.
Yeah, in all the rooms. I think if the slides are too...
Nice to see you. Thanks. Yeah, I'm good. I'm going away.
Okay.
Wherever I am at DevCon, it's like, oh, you will be there.
Then it can't be that bad, right?
Yeah, I enjoy your talks because Okay, you have your style in doing this fast, etc., but you provide also huge amount of data in it. So.
I think that's normally what I want to have when I'm coming to a conference and to a talk.
Yeah, exactly.
Get new stuff, data, and something to look up later, yeah?
Do you have any guidance how to report the bugs? For example, I know one thing, when I use VirtualBox and I have like